Assalamualaikum and a very good afternoon to Dr. Rosna. My name is Fazira Natasha binti Gafar, and today I will present the coursework of Algebra MTES1104, Applying Vectors in Daily Life, specifically in Sport. So the contents are: the first one is 1.0, the introduction; 2.0, the application of vector in daily life; 3.0, the application of vector in projectile motion, specifically in soccer; 4.0, example question vector in projectile motion, soccer; and last but not least is 5.0 is the conclusion. So the first one is 1.0, the introduction. The term vector comes from a Latin word which means carrier. In mathematics, a vector is quantity that has both magnitude and also direction, but not position of an object. Vectors are generally taught in two different representations. The first one is the graphical method, where vectors are represented as arrows in a Cartesian reference frame, and the second one is the algebraic method, where vectors are identified by means of unit vectors of I and also J. I is in the horizontal x-axis, while J is on vertical y-axis. Moreover, vectors also may be visualized as directed line segments whose lengths are their magnitudes. From the diagram shown here, the direction is going upward, while the magnitude is the arrowhead points in the direction which is magnitude that has a value. And last but not least, the examples of vector quantities are velocity, acceleration, force, and also displacements. Okay, next we are going to move to the second content, which is 2.0, the application of vector in daily life. The concept of vector have many real-life applications, including situations that involving force and velocity. Therefore, these are some examples of application of a vector concept in daily life. So the first one is the situation of boat crossing a river. So if you see the diagram shown here, so the vector that we have to calculate is the velocity of boat and also the velocity of river. So when a boat crosses a river, there are two velocity worked together, which is the velocity of river and also the velocity of the boat. The direction of boat changes with the respect of velocity of the river. So the velocity of the river is dependent with the velocity of the boat, the direction of the boat. So the boatman find an angle for crossing a river to reach the bank of river straightly. So the angle between the velocity is represented as theta equals to cos -1, velocity of a river bahagi with the velocity of a boat. So the conclusion here, the velocity is the vector that we need to find from here. So the second one is the vector in gaming. So in games, vectors are used to store positions, directions, and velocity. The position vectors indicates how far the object is. The velocity vector indicates how much time it will take or how much force we should give, and the direction vector indicates in which way we should apply the force. Okay, we move to the third content, which is 3.0, the application of vector in projectile motion, specifically in soccer. So for this coursework, I have chosen the application of vector concept in sports, specifically in soccer. So this sport apply the concept of vector in projectile motion. Vector in projectile motion. So vector in projectile motion is defined when something is thrown or shot, it has a velocity. So the velocity is a vector, and it is most likely at an angle to the ground. The velocity is a resultant vector, as I said before. The horizontal and vertical vectors that add to that resultant are called components. So from the diagram below, we can see that the projectile motion, if an object is launched at an initial angle of theta with the horizontal, the analysis is merely accept that the initial velocity has a vertical component. So what are the vectors that we need to find? Here, the vectors that we need to find is the velocity. So to describe projectile motion completely for these cases, we must include velocity, as I said before, and acceleration, as well as also the displacement. We must find their components, which is the component in x-axis and y-axis, along the x and y-axis. Let's assume all forces except gravity, such as air resistance and friction, are negligible. Since the gravity is vertical, then ax equals to 0, and this means as the initial velocity in the x direction and to the final velocity in the x direction are the same. So how to solve this figure? How to find the vector, which is the velocity? So the first step is we resolve the motion into horizontal and vertical components. We bagikan dorong. The magnitudes of the component of displacement s along this axis are x and y. The magnitudes of the component of velocity v, it has a magnitudes from the x-axis and also the y-axis. So we can find the magnitude v from the x-axis is vx cos theta. Why it is cos? Because the theta is to the x-axis, and also the horizontal one is vy equals to v sine theta, where v is the magnitude of the velocity, which is it has a value, and theta is its direction relative to the horizontal as shown in the figure here. So the second step, we treat the motion as two independent one-dimensional motion from the x-axis and also y-axis, one horizontal and the other vertical. We use the kinematic equation for horizontal and vertical motion to find the velocity of the magnitude of the velocity. So in horizontal motion x-axis, we use the kinematic equation, which is v initial equals to vx, while the vertical motion y-axis, we use the kinematic equation that y equals to vy equals to v initial y minus gravity force times time. So the third step is we solve for the unknown in two separate motion. One is the horizontal and one is vertical. Note that the only common variable between the motion is time, so the time is same. So the last step is we combine the quantities in horizontal and vertical direction to find the total displacement and velocity. So for example, that we need to find the total velocity. Okay. For the velocity, for the total velocity, the magnitude of the velocity that we can find is we use the theorem Pythagoras concept, which is this one from there, and then we plus from the velocity of the x-axis and also the velocity of the y-axis, and we can find the magnitude of the velocity, which is the velocity is a vector. Last but not least, the example 4.0, the example question on projectile motion, specifically in soccer. So let me read the question. A soccer ball is kicked with a launch of velocity of 20 meters per second at an angle of 30 degrees above the horizontal axis. What is the value of the horizontal velocity component? So noted that horizontal velocity is in the x-axis, so we need to find the velocity in an x-axis. How? So the first step that we need to know is that the horizontal velocity is in the direction of x-axis. So the magnitude of the velocity given here is 20 meters per second. So the magnitude v is equal to 20 meters per second, and the angle of displacement is 30 seconds. Using the formula that I have said before, Vx equals to V cos theta to find the horizontal velocity at an x-axis. So therefore, we substitute the value of magnitude velocity 20 meters per second cos 30 degree. So we can conclude that the answer is 17 meters per second. So the answer is D. Last but not least, the conclusion. In conclusion, vectors are utilized in a day-to-day life to assist in the localization of people, places, and things. They are also used to describe things that are acting in response to an external force being applied to them. A quantity that possesses both magnitude and a direction is known as a vector. So, how to conclude that the vector is concept where it has both magnitude and also the direction. So vectors play a crucial role in physics and also mathematics as well as our daily life. This helps us getting an accurate measure of the outcome of an action. And this outcome includes the magnitude and direction of direction as well. And that vector will also have a magnitude and direction on its own. Last but not least, vectors are very important entity in mathematics as well as physics, as many of action in this to depend both on the magnitude as well as the direction. If the direction of those action is not taken into account, then the outcome will not be termed as right. However, with the help of vectors, all these equations can be integrated into a single equation. That's all from me. Thank you.